In this demonstration, I'm going to discuss points, or what is sometimes called tags. The words are interchangeable. So I'm going to select points, and this is the points overview. I'm going to select new point, and by default it comes up as an analog point, and because this is an alphabetical order, it comes up on the OPC port. So I'm going to change it to port 1, which is the Automation Direct port we created in an earlier demonstration. And as we see here, it changes. This button disappears and this OPC group disappears because this port doesn't have an OPC group. It's not an OPC type tag that we're trying to create. And the button disappears because this button signifies that there's going to be another editor to pop up. And this is the OPC Point Configuration. It's an easier way to collect the tag string from the server. So for example, the Automation Direct port would be like C100 for its source, so it doesn't have any more complicated string than that. All points have a tag name, and tag names must be unique across all points, ports, video ports. Everything that has a tag name, it has to be unique. Access rights is can the HMI read, write, or just write to the tag, meaning it doesn't read or have any alarms if it's a write-only tag. Engineering units is, for example, GPM or PSI or inches of mercury or bars or whatever. These are used to scale the point. If, for example, you had a 12-bit analog, you would enter 0, 4095, and then if you were using gallons per minute, for example, 0 to 500 gallons per minute, you would enter 0 and 500. So that when you access the tag and its process variable item, you would get the scaled value 0 to 500 versus the raw value of 0 to 4095. You'd also be sure to turn this on to instruct the point to scale it. Otherwise it defaults to 0 to 100. Normal condition status is just the text to show when it is displayed that the point is not in alarm. Some protocols and devices store data in 4-byte fields instead of 2-byte fields. For example, Modbus stores everything in analog in 2-byte fields. So if we want to get 4 bytes from it for a float, we have to tell or instruct the point to access 2 bytes. So for in this example, it would access C100 and C101 if that was the case for Automation Direct. OPC Publish we talked about in another demonstration. If you're using an OPC server, it instructs the HMI to publish this point for clients to be able to access it. If it's not enabled, the OPC clients will not be able to see this particular tag. Alarm group is a way to group alarms by type. For example, a pump 1 or pump 7 or cooling tower 9. It's just a way to make it easier to access the alarms by group. If you just want to see the pump alarms, you would say I want to just see alarm group 1. These are the alarms. These are rising alarms. These are falling alarms. This is the limit, meaning that when does the alarm go off. This one, for example, could be set at 480, and this one could be set at 460. It's a rising alarm. This alarm would go off first, followed by this alarm if it made it to 480. You have to be sure to enable the alarm, otherwise the HMI will not check these values. Deadband is the amount of full scale that the alarm must return to before the alarm is considered not active anymore. So the alarm must go equal 480 or above to go into high, and then it must go below 480 plus whatever the percent of full scale that you enter here. If you enter 5, then it's 5% of full scale. So 480 minus 5% of full scale before the alarm is considered not active anymore. Sound is to play a sound when the alarm goes active. For example, you could say high pump pressure, left skid, whatever. You can make the sounds that you want. Log is to log it to disk. These next fields are all text fields to give more information to the user about the particular alarm that's active. alarms are latched, and the user must acknowledge the alarm, and it must return below the limit in the deadband before the alarm will clear. This is to prevent alarms from occurring and then disappearing before the user has a chance to acknowledge it or to see the alarm. Auto clear is an auto acknowledge. So the alarm would go active and then be able to return to normal, and if the auto clear is selected, it will return to normal even if the user hasn't acknowledged it. Print is to send to the printer if one is configured. If you don't have one, you don't need it. Notify is to send an email message that this point has gone into alarm. We've discussed that in another demonstration video. These other fields are all the same as the high, it's just their condition. So these are rising alarms and these are falling alarms. This one would hit first rising, and then this one, for example, would hit first, and then this one on a falling alarm. The next one we're going to talk about is digital. Digital has a tag name and description just as the other ones. It has a source address. So for example, if this was Modbus, it would be a input. It would have the same for Modbus. It would be read, because these types are only read. They can't be read, write, or write. Engineering units is just a text field to define what this is. A door state, for example. This is another text field to demonstrate the status of the alarm when it's not in its other state. Initial value is used to set the initial value because the alarms are edge triggered. So for example, if you had a condition that was an alarm on 0, if you first started up and the first valid read came through and the state was 0, though it is an alarm, the HMI wouldn't consider it an alarm because it hasn't triggered from 1 to 0. So if you set the initial value to 1, on the first valid read, if that bit of data was a 0, it would trigger the falling contact open alarm because there has been a change of an edge trigger, a change of state. Invert is just to invert whatever the external device is reporting. It's just inverted in the internal database. OPC published alarm group is the same as for analog. These fields, I should say from this field down, is all the same for analog or digital. This is just falling contact open. This is rising contact closing. And that's it for this demonstration. We're just going to cover the first two in this one. There are 2 more videos to cover these other 6 points.